Good morning, everyone, to our ERCI webinar. This morning, we are dealing with artificial intelligence today, and the title is AI, is it a game changer for railway operations and maintenance? We will have two interesting presentations from two speakers, and I'm in the middle to introduce you our general agenda. We have two speakers on this general topic on AI, a game changer for rail maintenance and operations, followed by a Q&A session. But normally we have some questions and answers after during every presentation. So please use the chat function for your questions. I will collect the questions in the time the speakers are presenting, and then we have a slide indicating all your questions. We use the end of the webinar normally for announcing you some news from the ERCI network. There will be interesting news on ongoing project, on funding opportunities, and next webinars and events. So be excited what it is. And first, I will start with a very short introduction of the ERCI network. We are existing since 2010 and legal entity since 2022. These are 18 railway clusters covering 17 European countries, and we are representing over 3,600 enterprises and research institutions, universities, incubators, accelerators. The most of our members are small and medium-sized enterprises. ERCI is managed by nationally regional focused clusters, these 18 clusters. And yeah, these are the main services we bring to our members. It's all about bringing customers, suppliers, and supply chain opportunities together due to supporting especially small, medium-sized enterprises, detecting new market opportunities, partner matchmaking in research and development, enhancing their visibility on international level, maybe also due to the annual ERCI Innovation Awards. We will have a slide later on this special topic too. On dealing with innovative topics which have or might have a major influence to the future railway system, like cybersecurity, multimodal logistics, green and sustainable mobility, and human factors. And we are providing several networking opportunities like webinars and workshops, networking events, fairs, and business trips. So I will hand over to my colleague Guido from DTEC Fair because on multimodal logistics task force there is some news to report.
Yes, thank you, Lutz. Just to introduce this slide, which was the introductory slide for this event organized by DTEC Fair and ERCI, which has occurred on the 26th of February in La Spezia in Italy. We have gathered information about this military logistic and non-military logistic aspect that are important since at least 1 year, but maybe more at European level. Therefore, we have organized this event where we have made a kind of summary of what has been done up to now and what will be done in the future on military mobility. And what is interesting is that it's not a standalone event, but we will do a further one in 3 months' time. So having this information, if you have elements that you would like to share with us in order to be a speaker, to be a bringer of information or on activities that you are doing on military mobility, you are more than welcome. That's it. Lutz.
Yeah, I think you could just overtake this slide before introducing our first speaker. But you made the job with the chat. All contact data to ERCI are visible in the chat. And we are for sure present in the internet, in LinkedIn, and for sure we have a general email address. And that hands over to our first presentation. And as the first presenter, or the company of the first presenter is a member of DTEC Fair, I will again hand over to Guido for a short introduction.
Yes, I'm very glad to introduce you Gianluca Mandò. Gianluca is Innovation Manager at Hitachi Rail GTS Italia, with vast experience in developing technological solutions and products within multinational companies such as Marconi, Leonardo, Thales, and Hitachi. Throughout his career, he has held increasingly senior technical management roles in the fields of telecommunication, artificial intelligence, and vehicle autonomy. He has coordinated corporate research activities in dozens of European and national projects, leading to the publication of articles and the filing of several patents. Gianluca, the floor is yours. Thank you.
Thank you, Guido, for the introduction. I'm trying to show my presentation. I suppose you are seeing it. Let me put it in show mode. Okay, you should see it now. Okay, good morning, everybody. My name is Gianluca Mandò. I am, as it was said, Head of Research, Technology, Innovation, Hitachi Rail GTS Italy. Our actual main research trend, and the one I will present today, is on technologies for autonomous tram. And today I'll try to give you a picture of the main pillars of tram autonomy, on how sensor fusion, machine learning, and AI technology contribute to it. Let's start a little bit of context. Since the last few years, we are seeing a transformation in all kinds of transportation and also in trams. Traditional trams are leaving the floor to new ones, having a higher level of awareness of what is going on in the tram surrounding, less dependent on the wayside infrastructure and more rich of autonomous function. For sure, to do so, we require facing different challenges. We need higher performance hardware, updated safety certification, updated regulation, and high performance network to exchange large quantity of data. These challenges are not yet completed, but progress have been without any doubt made, and other will come soon. To be prepared here in Hitachi Rail, we started addressing a few problems that enables full autonomy operation. Connectivity was the first one we addressed, targeting from the beginning 5G, that is giving us a lot of function for increasing the reliability and reducing the latency of the communication. Then we started addressing safety positioning and perception awareness. In this roadmap, we are halfway, we have to say, to full autonomy operation. Now, let's start a little bit on what could be a concept of autonomous tram, at least what is my view, our view here in Hitachi Rail GTS. From a logical functional perspective, the architecture of an autonomous tram can be described following the flow of data from left to right in this slide, from sensors to system actuator. Identify the three main stages: perception, planning and decision, and motion and vehicle control. The main goal of the perception stage you can see represented here is to receive data from the sensors and other source of data like track line geometry database. We need the knowledge of the track line in order to generate a representation of the vehicle status and the model of the external environment. For performing this task, we we are using two different set of kind of sensor, let me say. We have categorized them in proprioceptive and exteroceptive. Proprioceptive sensor are thus used to determine the ego vehicle cinematic state. It can be GNSS, natural measurement unit, radar, encoders installed on board, like odometer or tachometers. These are used usually to calculate the position, the speed, and the heading of the vehicle, so the ego motion of the vehicle. The other set of sensor is the exteroceptive sensor, and as the name is suggesting us, they are used to monitor the environment external to the vehicle to obtain data relevant to the environment and to the external object. It can be, you can identify here cameras, LiDAR, radar, all of them supporting us in identifying the external environment. After collecting all this data from these two sets of sensors, two main functions are performed in this perception stage. The first one is localization through our next generation positioning system and gap, and the environment awareness, alias perception, that is based, in our view, on obstacle detection and advanced driver assistance system for the moment, and track line, and this signal aspect recognition. After this stage, we have the planning and decision stage. That is used for considering also external signaling rules and journey information. We can start with this stage the service and request for the route to the signaling system. Like as an example, a short-term route from point A to point B approaching a tramway junction area. We need a building block that is called the reactive route control, coming from the perception stage. To implement the safety operation of the vehicle in order to prevent collisions and collision action, preventing collision actions are example of what is played here. As per standard tramway signaling operation, this stage should also include the predictive route control, receiving information for the knowledge that already have as a basis from an external system to operate safely, like signaling rules from the signaling system, like the interlocking, the maps update, the routes update, and the digital horizon in general can support this stage. The stage of motion and vehicle control, instead, in my view, manage the way in which the trajectory generated in the previous stage is executed, is carried out on the platform, considering the configuration, the track geometry, and the limitation of it. Finally, the motion and vehicle control interfaces the tram system through the physical actuator. So this is the picture I would like to give you to understand better what we have done in the last year, mainly in Florence, and where we have a real tram autonomy test environment, where we had the opportunity to verify the implementation of the component presented until now. In fact, we developed in the last year the NGAP, as I said before, to determine in an accurate value the cinematic parameters with a high level of reliability. The data feed that is from the sensor are fed to the sensor state-of-the-art sensor fusion algorithm developed in our lab in the past, that is based on a Schenker-Kalman filter and only algebra. It is able to maintain on average an accuracy of tram localization below 1 meter for the entire 20 kilometer of lines here in Florence, with an average of speed accuracy below 1 kilometer per hour. we are able to keep this level of performance also in case the satellite signal is not good. We don't have coverage of the satellites. In this case, we are going in that reckoning, keeping the same level of performance up to 2 kilometers and half. The second component we have tested in Florence in this tram. We had 3 trams in service in Florence for performing these test campaigns. Is the obstacle detection and tracking system that helps the driver in avoiding collision and reducing the consequences of unavoidable collisions. Both the system has been designed from scratch by ourselves in our labs. And for the obstacle detection system, we identified the solution able to minimize the number of false positive, false negative rates that are very key for in terms of availability and in terms of safety of the system. This test campaign as this development at the end generated also several patents. This video to show you an example of what can be done with our next generation autonomous position, in particular the view of the sensor. I wanted here to show you what are the data that our sensor fusion is receiving from the sensor. You can see in the last column on the right, the speed calculation on the upper part by the GNSS and the speed calculation by the radar on the lower part. You can see the shape is the same, and this is testifying the very accurate measurement capability in terms of speed made by the satellite system, GNSS, multi-constellation system, that is very reliable in terms of speed. On the previous column, you can see here the output coming from the angular acceleration and the linear acceleration of the inertial measurement units. The most important part in this picture, in this video, is the row in the middle, where you can find with the blue dots, very small, I know, but you can see here blue dots for the position and for the speed. Calculated, this is the output of our sensor fusion algorithm. Calculated. Can you hear me? Yeah.
Yes, we can hear you.
Yes, I heard some noise. So this is the error calculated by comparing the outcomes from our sensor fusion algorithm and a ground truth that in our case was an augmented GNSS solution, RTK, real-time kinematics. You can see here that we have also other lines. That is an example. The green line that is the standard deviation error in coming out from our sensor fusion, and the red line that is the protection level, very key parameter, very important for the certification of this kind of application, that is the safety radius within which you can be sure with a high level of reliability that the vehicle is positioned within this radius. This is very key for certification. This is how we installed the sensor aboard the vehicle for object detection and localization. You see the sensor installed behind the mask. For sure, we obtained the authorization of the Ministry of Transportation for doing this because these are real in-service trams. So they were running all the days performing their services. Here you can see the physical architecture, high view of the physical architecture, where the localization system is supposed to be external to the ASA system, but in some cases can be combined in the same onboard computer. Sensor, you can see a sensor installed on both the cabins, and everything shares the same network, the infrastructure, because communication network is the same. A single high performance computer is enough to handle both cabins. Sensors are usually used on active cabin only, so only the active cabin enables the set of sensors, relevant set of sensors. We collected a lot of data in our several years of test campaign, increasing our performance, maturing our product solutions. So we have a big amount of data on which we continue to develop and to mature our algorithm on actual data, not on synthetic, even if we have already also implemented some synthetic tools for the sensor fusion algorithm an evaluation of the performance. Because we are here in a meeting that is addressing the application of artificial intelligence in transportation, I wanted to show you an example in particular of the application of artificial intelligence, in particular convolutional neural network, in one particular detection chain of our perception system, the ODT ADAS. You can see here a pipeline explaining in greater detail the operation that are performed by the object detector that works on a couple of stereo cameras. Okay, you can see two cameras, a couple of images coming from the two cameras that are synchronized, that are undistorted and rectified in order to remove lens distortion. A couple of images are processed in this way, are sent to the planar object detector. In that case, at the time, it was a YOLO V4 with the customization, our internal customization, and training on real tramway data, as I said before, and to stereo depth estimation stage. Okay, after this, we have a couple of disparity maps that are projected on the 3D space. The small video shows here on the right an example where pedestrians and vehicles are detected. The detected targets are highlighted in red. The LiDAR point cloud is also here shown for reference. And the results can be seen here in this video, where you can see the projection in the depth in the 3D scene, starting from 2D images of the object that are identified by our video 3D detector based on stereoscopy and artificial neural network. Okay, just coming now to analyze which are the main functions that our obstacle detection and ADAS system is able to deliver on the market. We will see also some example of them. First of all, we are able to perform a forward collision warning. So a LiDAR-based obstacle detection is searching along the track line to see if there can be any kind of obstacle at a certain distance from the vehicle. Then we are able to perform object detection and tracking in the entire field of view of the sensor. We are able not only to detect them, but also to track them in their movement. So along the time, in the entire field of view, we fuse all this measurement that are coming from the sensor in our sensor fusion algorithm and tracking algorithm. We are able also to classify objects and to evaluate like pedestrians, cyclists, and vehicles, as I wrote here, but also others. And we do this in order to avoid possible collision with vulnerable mobile objects. In particular, we consider here mobile objects. We are able to monitor the speed of the vehicle, the ego vehicle, and the speed and the dynamics parameters of the target that we see in the external environment. In this way, we are able to generate alert to the driver. An example of this, of the first function is the forward collision warning, where in this function we scan a 3D volume along the railway line, ensuring that the tram's gauge is free from obstacle of any kind. It is not interested the system in any particular class of object. It doesn't even try to classify the object, I have to say. It just have to say if the volume that the tram is going to occupy is free from obstacle or not. The LiDAR here scans the volume by projecting laser beams with a given geometry. If there is an object in the volume, the beams will be reflected back at the sensor, which is capable on the vehicle of measuring the time of flight of the light and thus the distance of the object. What is interesting here is the same object seen at a shorter distance produce more reflection points, since the laser beams are emitted at fixed angle from from the device, and they diverge as they move away from the sensor. This plot show how many points we expect to receive from the LiDAR for objects of different sizes in function of the different distances. Here, some use cases, example of use case that we addressed for considering the generation of alarms towards the driver in the first step. Then we are considered also to send them to the operation control center. Here, in this example, is okay because the free distance seen by the sensor is longer than the braking distance based on the speed of the vehicle. So there would be enough time, enough distance to brake without having any collision because the free distance is longer. This is instead the vice versa, the opposite. The driver is speeding up a little bit, so the braking distance is overcoming the free distance, and in this case there will be not enough space to avoid the collision in case an obstacle will appear at the edge of this lane. This is another use case generating an alert because there is an obstacle on the track line and automatically the free distance is reduced by the presence of this obstacle, and braking distance in such a way is overcoming the free distance, no enough space to avoid collision. We have the specular case. We have an obstacle on the track line. Yes, we have it, but fortunately, the speed of the vehicle is not so high, so the free distance is greater than the braking distance. We have enough time to brake the system, the vehicle. Again, this is generating an alert because the presence of a person aside the track line is reducing the free distance from the potential visibility coming from the sensors because of the presence of the obstacle. So braking distance overcoming free distance and so on and so forth. So other example, giving us what are the cases for generating the alert to the driver, what is not the case to generate alert to the driver, and in a second moment to apply the braking system. Okay, in our solution development, first research and then product development activities, we decided to give a feedback to the driver. So we started with giving simple feedback like sounds, specific sound through the loudspeakers, up to generating some, activating some LEDs of different colors, up to arriving to design a real and complex HMI for the driver. You can see here what we did using the support of internal UX UI experts. We show a representation of the RAILwAI within the sensor max operative range with indication of the free space of the object of interest in the surrounding. Also the speedometer, you can see in the upper part of the HMI, show the current speed compared with the maximum allowed speed. We think it to be the first in the RAILwAI market to have done this kind of design, because you can find them in the automotive market, yes, automotive self-driving cars, so with some autonomy function. You can see this kind of HMIs, but in RAILwAI probably we were the first. Okay, in this video, that is based on real data, so it's an application working on real data, not a fictitious video. You can see in the lower part a summarization of what I have, a summary of what I have done, said until now. The confrontation comparison between green line and red line, detection of the object by using stereoscopy, the representation of the raw data and detected data, and the track of them in our 3D viewer in the lower part of the picture, and the HMI I showed before on the right part of this video. You can see the red lane that is because the tram started, it is approaching the green lane up to we can see after the overcome, like in this case of the red lane respect to the green lane, you can see an alert has been generated. Okay, I am on the last slides. Just to give you some preliminary results that we are having in a new topic that we are addressing for our products. That is AI-based, because we are speaking about AI here, AI-based track detector. So using a new version of CNN YOLO, version 11, we have done a modification of the segmentation head of YOLO, so our internal modification. That has been also retrained with data from our internal manually annotated dataset. The annotation tool used here are two, SEM2 from Meta, and the proprietary tool designed to refine the annotation obtained from SEM. A remarkable aspect to consider here is that the CNN model has been trained with only 15 minutes of data, only 3 videos, 5 minutes each. And only after these 15 minutes of annotation, the quality is very good, achieved in such a minimal effort, suggests us that this method has a great potential to become highly robust and effective. We are taking also the measurement, we are measuring all the parameters in order to have also a quantitative demonstration of this. In the coming weeks, in fact, the training will be set and will be expanded to include the different viewpoints, image from other public data set, and the data augmentation phase, which should further improve the method's robustness, even in scenarios where the viewpoint is not exactly the same as in the training. Okay, last slide. This slide just to tell you again, linking to the beginning of my presentation, that not all the challenges has been solved. In particular, the part relevant to the standardization, how the new standards like 5176 that is replacing 5128, the standard relevant to the software development technologies for RAILwAI application, safety RAILwAI application, I was saying that challenging are still alive for this new standard. In particular, they identify the four kind of challenges. The first one is ensuring that the training data are sufficiently complete and accurate. This is a key point because they are assuming, they want that the training data has to include enough cases to make it sufficiently unlikely that the situation not represented in the training data will be actually occurring in practice. So they are saying all the training data set has to include also the specific and very particular cases. And this is an issue that also the automotive market is addressing, because the major part of use case are already solved, but there are some specificities that cannot, what is unexpected that cannot be today solved also in the automotive market. So RAILwAI is saying this here, is saying that also this particular case has to be considered in the training data set. Verifying the training software. This is an issue because, you know, neural network, we cannot have a complete view of the neural network because neural network architecture is based on the weights of the neural network, and they change according to the training. So the architecture is the same, but the weights of the architecture continuously change according to the training data set. So what will be the way to verify this kind of architectures and to validate them? And then there is the last point, adversarial attack should be also taken in consideration for protecting this kind of application. So a working group has been started by Senelec to work on this amendment, to an amendment that is providing more guidance on artificial intelligence machine learning usage in the world of the RAILwAI. Okay, this is I finished. Thank you for attending this presentation. I'm open to answer your question if you want.
Thank you very much, Gianluca. I know that there are several questions. Maybe I ask you to answer shortly, because then you can maybe detail your answer later on one-to-one discussion after the webinar. So the first question is, how do tram autonomy contribute to improving the efficiency and safety of autonomous tram operation?
Okay, thank you. Guido, for sure, tram autonomy enhance both efficiency and safety, automatizing vehicle control and minimizing, or we hope by minimizing the human error and ensuring real-time responsiveness to dynamic urban environment. Safety is reinforced through, in my opinion, through a continuous monitoring of the environment, enabling rapid response to the obstacle, more rapid by the machine and then by the human, and take into consideration adverse weather conditions and unexpected events.
Second question, what are the main technological challenges in developing an autonomous tram system, and how is Hitachi Rail GTS Italia addressing them?
I said before with all my presentation, we started from this communication, but that immediately after going to work in the positioning navigation field, achieving a very accurate sub-meter positioning measurement. We address a new way to generate autonomous positioning, combining a different sensor. In terms of obstacle, instead, the second technology, we take particular care to ensure that the system can be reliable, can be in detecting and track the obstacle in order to reduce the maximum the false positive rate and the false negative rate for both availability and safety of the system. These are the main topics that we address.
Thank you. Next question is, for connectivity, you have indicated 5G. Is the communication only for data or also for voice transmission? Will you use FRMCS in the future when it will be available, if applicable?
Okay, thank you. 5G, yes, is the one that was, it is today the most promising technology for specific service, ultra reliable and low latency communication that according to the standard should allow us to have a very short delays, so less than 1 millisecond in theory, allowing us to have a unique way to communicate with the local infrastructure, but also with the operation control sensors. So I am answering to your question because with a unique way of communicating 5G, we will be able to manage voice, signaling, and non-traffic data information. We will not use probably FRMCS. I say probably because FRMCS today is not on the field. But also I say this also because tramway is running mainly in the smart city, in the cities. So FRMCS mainly instead has been designed and specified for a standard main line. So this is the difference.
Thank you. As far as the definition of the system is concerned to assess the safety, do you consider that the satellite is part of the system and by consequence part of safety case study?
Yes, we think, and this is directly what we are doing, we will do this year, including the satellite GNSS receiver within the chain already certified without including the satellite chain. So this year we will include the satellite chain in the certified system that in collaboration with our colleagues in Canada, we have already done, and for that regards GNSS, we will do this year. So it will be part of this certified system at the end of the day.
How the system has the capability to manage and react when it is a false alert?
Yes, this is a very key question. We worked a lot on this because we had clear in mind this potential issue. We designed our architecture from the beginning considering it. So we identified an algorithm patented by ourselves that it will be able to mitigate and strongly reduce the number of false positive, so false alerts during the service. It is a patent. I cannot say more, but I can say that could be the performance. It is a performance that can drive us to have one false alarm per week per vehicle. This is our objective, and what is our calculation, our mathematics is saying us.
Okay, last two questions. Are you considering related development of external warning signals that can also be used for avoiding wildlife animal collision on main lines?
I would say yes, but for sure, integrating different external systems or measurements coming from different external sensors, we need to understand for sure what is their internal capability to generate false positive and false negative, because this will impact in our architecture and in our performance, giving a final rate in terms of false positive and negatives.
Yes, I imagine that animals collision on main lines, but it can happen also on a city environment. But
Yes.
then we have all the discussion about static and dynamic obstacles. I imagine that this also impact your system.
Yes,
Because
in
a
fact,
static box is something, while a person crossing the tram line is something else.
exactly. You're right. And this is the reason why we decided to not only implement a detection system, that is the majority of the product in the field today, but also to track, to follow the targets, to understand before, with a certain level of prediction, if they could become obstacle or not.
The system is capable to read the light signal, isn't it? What in case of a
Yes.
derailment or for the traffic disruption, for example, unavoidable crash?
Okay, I'm not sure to have got the entire question, but for the first part, for sure, what we have in the roadmap and we start already to develop from the last year to this year is the railway signal aspect recognition. It means to be able to recognize the signal aspect, to give this information to the driver and to the operation control center using artificial intelligence. So this is another important feature that we have in our roadmap. Regarding the second part of the question, I'm not sure, but if I well understood, in case of there is this downgrade of the situation of the scenario with some crash in this coming probably in the area close to the track line, to the tramway line. Yes, in this case, we can have some mitigation because we are able with our sensor to detect this potential incident that is happening in the front of the tram, and the tram has the capability to apply the braking system and stop the vehicle, or try at least to mitigate the incident.
So,
Thank you.
Lutz, may I interrupt you? I guess we have 3 more questions, but the time is running, and therefore I would propose that you, Gianluca, might answer to these questions directly in the chat. You will find them in the chat. I only copied and pasted it into the slide, and would now hand over to my colleague Daniela from Millennium in order to introduce the second presentation. Thank you.
Good morning, everyone. Thanks, Lutz. I'm so happy today to be here on behalf of my colleague Amélie Espero, who is not able today to be with us, and too happy to present one of our member in iTrans, RAILwAI. Today we are together with Jean-Michel Estivan. He is a co-founder and the president of RAILwAI. RAILwAI, or Rail with AI, is an innovative company providing railway infrastructure predictive maintenance. It is a young company established in 2021, but well recognized for its innovation. In 2023, Propulse laureate organized by the French Innovation Agency for Transport, and in 2023 also European Startup Prize for Mobility organized by the European Transport Commission, recognized the work of our company here. And Jean-Michel, the floor is yours. Please take a lead.
Thank you, Daniela. Thank you for the introduction and thank you for the invitation. Let me share the screen and you will let me know whenever you see my slides. Once again, RAILwAI, as Daniela mentioned, pretty much most of the value proposition is in the name. It's AI for the rail, and how to use and leverage data science to be able to provide predictive maintenance. Hold on. Can you see my slides? Nope. Okay.
Not yet.
Let me.
My screen is just shared with the title of your presentation.
Okay.
Now it seems, yeah, we see some other, but not the presentation.
Okay, it should be
Maybe
coming.
you have to share another screen. Yes.
Okay,
Now
now
you
you
can proceed.
Okay, good. Thank you. So once again, RAILwAI, and the aim at RAILwAI is to see, how we could be moving from not using the data to using the data, and how we could be a real game changer in terms of the way we do maintenance, especially at a time where train transportation is becoming critical, in terms of being able to do a modal shift from high carbon transportation to low carbon transportation. Let me give you and share with you a couple of market pains we assessed before starting RAILwAI. On one side, infrastructure has never been so digitalized. I mean, you got data anywhere, from sensors, IoT, inspection wagon, even, digital forms. But what we found is actually very few of this data is actually being used. Less than 15% of the data are actually being used in terms of analysis, while there are so much potential to go for even deeper. The second point is actually, we spoke initially about how rail transportation is a cornerstone of the future modal shift from high carbon to low carbon. However, in Europe, and it's based on EU data, over 10% of the trains are late or cancelled, 45% because of infrastructure issue, which is not a good sign if you really want to do a modal shift from high carbon to low carbon. Third one, analysis at this stage are mostly done in silos, not with a 360-degree view. We have, analysis on ballast profile, analysis on rate geometry, analysis on, catenary geometry. But you would not, very few cases, provide a real full 360-degree view. Last but not least is actually maintenance at this stage is essentially preventive and corrective. In both cases, it's not time and cost efficient. Moving to what we have been aiming at doing at RAILwAI and our value proposition. One is to be able to leverage all available data. Our solution is not a black box, meaning we are able to include any available data on the infrastructure. Not only data which are available today, but if tomorrow you would have more data or more sensor, more whatever, you will be able to provide additional extended information. Two is to provide advanced analytics, which is both a mix of cross data and AI, being able to cross-check analytics and not just have some silo information. What could be the evolution of the ballast profile on the overall catenary profile, and what would be the impact of having a nearby bridge or tunnel. That's the kind of analytics where we believe it will provide some value. Third is to provide contextualization and failure signature, to be able to have within such context, we would have such failure signature, and therefore being able to say, okay, there will be such a failure within this geographic time frame, such PK, kilometric point, and as well as within this time frame. So we can say within 3 weeks you would have such failure as such a kilometric point, and therefore you are able to do some predictive maintenance and not preventive maintenance. What we'll see in the demo later on, it's a mix of AI predictive models as well as data science. And of course, the latest modules we have been developing is an automatic connection to our customer maintenance automatic platform, CMMS. So, we're able to not only predict and provide some context in terms of failure detection, but also to be able at some point to really feed them into, our customer maintenance platform. Typically, the ROI we are targeting is not only to reduce the train cancellation and to improve infrastructure availability by 30%, but also to reduce the maintenance cost by 15%. And that's the typically ROI we've been experiencing on the different use case we have been experimenting. Typically, our targeted customer could be infrastructure managers, transportation companies, engineering companies, construction companies, sensor suppliers. The way the solution is architectured is we have a central piece, which is the data station, and I will give you a brief demo about what's in the data station. It's pretty much a data warehouse with a spatial data model that has been designed for a 360-degree view across, whatever kind of maintenance you'd have on the infrastructure. And then we have 6, and on the data station, it's mostly data science. There is no AI being embedded into the data station. And then we have 6 different modules. One is on geometry, being able to look at, the different elements on geometry, both for catenary and signaling, and tracks and catenary. One which is signaling, really focusing on the signaling element. One which is on traffic, and what we are doing is not, related to rolling stock, but at the same time, the traffic is the only modules where we are connecting to rolling stock in terms of making sure what is compliant versus what is the compliant traffic versus non-compliant traffic, which is the right loading by axle, which is, do we have compliant wheels or not wheels? So what will be the impact of non-compliant traffic on the infrastructure? Weather would be, some higher supervision and prediction during hot season and cold season. Inspection is a module based on, providing analytics around inspection of wagon and all the different data being fed into. And MIDA, the last one, is actually the module which is providing the connection to the customer CMMS. Today, I'll give you a quick demo on the data station and the geometry, but you will have more information about the other modules on our YouTube chain, on the RAILwAI on YouTube or on our website. Of course, the solution is SaaS-based, based on subscription and different implementation costs. Let's go with the first one. In terms of testimonial, let's look at the persona. You're the chief operating officer. You're in charge of the operation director. You oversee all the different maintenance teams in the area. And before you had to, in terms of getting consolidated information, you had to chase all the team members to get updated performance indicator, maintenance status, budget tracking, and it was a huge time and energy consuming solution. And this persona typically needs to have a clear view with a clear KPIs, with a full 360-degree view about the infrastructure. So that's where the data station jump into the equation, where what we will do is to be able to put in the same place a solution where you will have all the different data being aggregated and all the different information available. So as a quick view, typically what we have here is before RAILwAI, you would have to do all the manual KPIs, update and scattered all over the tracking and multiple entries. You would have the lack of responsiveness to obtain all the reliable information. And it will take quite a lot of time to get all this information being, put into the right format. Now, with this central data station, which is data science at this stage, you would get all the information. You would have to reduce the operational cost, increase productivity, and improve strategic management in terms of visibility. If we go quickly through the platform, so you could go through the different elements in terms of dashboarding. You would get all the different sources, and you would have all embedded KPIs in terms of having as a snapshot a view of the different elements of your infrastructure availability and the different maintenance you're providing on the infrastructure. Of course, in terms of visualization, you'll get everything from gauges, from trends, from spider charts, from whatever. Keep in mind that one of the elements we have been putting together at RAILwAI, half of the team is coming from the rail management infrastructure, and half of the team is coming from the data AI management side. So all the KPI developed are actually, something that has been developed especially for the rail management industry. So at this stage, in terms of benefits, we are not talking about AI. We are only talking about capability to be able to provide all information about tracks, catenary, signaling, all the different bridges, tunnel information into one central repository, and to be able to do cross-data analytics and to be able to provide KPIs. No data, no AI at this stage, only data science, but that's the cornerstone of the solution, which is being able to provide all information in a central place. Now let's move to the geometry module. with a different persona. In this case, let's say you're the rail maintenance engineer. You're in charge of the infrastructure safety and reliability. At this stage, you are getting different information from different sources. That could be your sensor, it could be inspection wagon. But at this stage, the different information you are getting are not taking into account specific of railway asset. What is there any bridge or a tunnel nearby? What could be the impact and so on? On top of it, there is no memory from one recording to the next. So you would have to go. Whatever analytics you would do on a run, you might lose it versus the next run. Also, you would have to realign records because sometimes you would lose the GPS information, you lose the GPS signal, and therefore you would have to realign everything to make sure you are at the right kilometric point and so on and so on. And you could not see how the defect would have progressed. Same thing, with railway, being able to put it in the right format with the right analysis, and we'll see the demo. You are able to do some cross-referencing. You're able to automate, all the different alignment of records, to look the defect evolution over time, and of course, to suggest on its origin point. If we look at, what it looks like at this stage, once again, if we look at the overview demo, so you would have an overview of the different defects classified in 3 categories. That will be green as they identified, but at the same time, there is no major operation to run it. On the other side, you will have the red one, which you need to have some operation right away on this defect that might disrupt your traffic operation. And the orange one is the one that you have to plan very quickly, but there is no urgency in terms of doing it. So you'd have the list of the different defects. If you click on the star button, and that's where we start on the prediction, you would predict where we would be within a specific time frame. And in this case, how many would move from green to orange, how many would move from green to red, and so on and so on. So that's the first piece in terms of AI, being able to build this predictive part of you have a list of defects, and you're able to see by just using the different predictive algorithm where it could be. Of course, you would have a mix of elements where you could go and zoom in on the different defect, get information about the landscape, and so on and so on. You could move on different tabs. You have one tab which is analysis, so you can get all the different elements in terms of analysis about the defect, what was the origin, how it has labeled, and so on and so on. You will get all the different data information about, you are able to drill in and down in terms of getting to the maximum level of information and being able to put some comments and labeling about the defect that you have. You have, if you have a tab in terms of history, so you can see, the different history in terms of run, how it was evolved, how it will get. And if you look at this one, you would get, a curve where if you look at the lower left corner, you get, a red line, which is where you need to intervene. You have the orange line, which is where it's best to have an operation. If you go below, it's not cost efficient. If it's above red, it's not cost efficient as well because it's too late. So the point is to be between the orange and the red line to make sure you have the right timing for the operation. If you look at the lower right corner, also one of the major issues we are seeing is in terms of realignment of GPS signal to make sure that if either you lose a signal from the GPS or you go after a bridge or tunnel and you lose a signal, we are able with our algorithm to realign the traffic curve to make sure that we are within the right geographic frame. Getting more in depth, so we are able once again to really drill down, up, or whatever to get all the different information you need to be able to forecast your prediction and not to do some preventive maintenance. Keep in mind that before railway, it was field survey to identify the root cause, inspection wagon not taking into account all the railway assets, GPS failure, recording were isolated. At this stage, we are able to provide suggestion on the root cause of defect, automatically cross-reference of course, with the right visualization and alignment with historical traffic. Mean better quality, time saving, and improved railway safety. In terms of moving forward, we have only, as we were limited in terms of time, we only had 2 demos, but once again, you have more demo in terms of module and more in depth on our website and on our YouTube channel. Keep in mind that the core benefits of applying AI and data science for infrastructure maintenance is moving from reactive to predictive maintenance with a 360-degree view, having a large scope of use case, which is, of course, metro, tram, anywhere where you have guided rail, you could apply the solution. It has both a social and green impact in terms of being a leverage to move in terms of modal shift, but also it has a strong cost benefits in terms of reducing the maintenance cost by 15%. Thank you for your time. And of course, if you have any question, I could either answer them online or, I could answer them later on.
Here are some questions, Jean-Michel. What about if there is no data available on the infrastructure?
Okay, actually, that's a very good question. And, we were worried initially that, we would face a situation where we would have no data. First of all, the good news is in most cases, we have plenty of data, and in most cases, the data are actually not being used. Also, if there is no data, and actually that's a project we are working on, which has been funded by the French authority, which is to be able to develop our own inspection vehicle, which will be road rail, with all the different lidars, captors, sensor, cameras, and to be able to do our own run to get the data, and of course it will be fully integrated with our solution. So in the case a customer has absolutely no data, we could come with our own inspection vehicle and do the full inspection and the full analytics very quickly. As everything will be integrated.
Thank you. Are we ready to let an AI agent manage rail maintenance and security?
Well, actually, at this stage, what we found with our customer and prospect is, of course, we are not in a situation where we are able to fully rely on an AI agent that will, fully fuel the predictive maintenance backlog and do full automation. However, at this stage, we are providing high-value analytics for agent, operator, and engineer on the infrastructure to make the right decision. For instance, on the inspection wagon, 10 years ago, pretty much there was no inspection wagon, so everybody was doing, on-foot inspection on the track. Now, with inspection wagon, people thought they were saving times because everything would be automated. But actually, now, the same engineer or technician is spending his time in front of his computer, looking at the different data and doing, okay, that's a true defect, that's a false defect. And we found that actually the time they were spending on the tracks, they are now spending it in front of the computer without saving really much time. What we find here is actually with our different use case, we've been saving like 95% of the time by automating the analytics. And therefore, the agent, the technician and engineer has more time to do real added value analytics. So Daniela, to make it short, no, I don't think we are ready for an automated AI agent, but at the same time, we are saving a lot of time in terms of automation and being able to do more analytics that was not done before.
This is nice to hear. Thank you, Jean-Michel. And the last one question here, it is about data ownership. How do you anticipate the regulation of data ownership, such as in specific country where they require high security standard and sealed data environment?
Okay, actually, that's a very good point. And we get this question very often from our customer and prospect. Data remain the owner of the data remain our customer and remain, that will be the manager, the infrastructure manager. So there is no question about it. The data remain within, the customer organization. What we do is we would use the data, we would leverage the data, we would, train our model on the data that will be anonymized before. So in the case, we can use and leverage any available data, but at the same time, it remains a property and it remains in terms of security part of the customer organization.
Thank you, Jean-Michel. And for the moment, the last one, at an early stage on a new application, are you considering using simulators?
Yes, we are considering using simulators. Of course, that's a way to move on, but I guess we can go far beyond just simulators.
Thank you. I don't know, Lutz, do you have any more questions? This is for the moment.
Yeah, I'm observing strictly the chat, and I have indicated no questions so far. But we have around 15 minutes left, so I would conclude with the next information, and via further observing the chat, if there is any question, for sure you are invited to use the chat functions for your questions. So thank you very much, both presenters, Gianluca and Michel, for their very interesting presentations. Thank you, Guido and Daniela, so far for this good introduction of our speakers and for the Q&A, leading the Q&A sessions. And I will now want to raise your interest to our very short questionnaire. We have a feedback questionnaire. We are interested in your evaluation of the quality of the presentations, and what is quite more interesting is if you have some proposals for new topics for next ERCI webinars, or if you are ready to say, hey, I could present my solution myself during one of our next ERCI webinars, please let us know. The link you can find already in the chat. So you can watch this ERCI webinar afterwards by going to the YouTube platform, YouTube channel of the Former Stars project. There we will upload all the recordings. Several recordings are already available, and maybe it takes 1 or 2 days that the recording of this webinar will also be integrated or visible at this platform. So coming to our next webinar, already the information is on new approaches to intermodal rail transport, and we have already one speaker available. It's also one winner of the ERCI Innovation Awards last year, as Hitachi GTS Rail Italia is it as well. And the second speaker is under improvement. We have already an idea how to manage it, and you can already register for this webinar. It will take place today in 4 weeks. That means on the 9th of April. And please be aware that then we are in the time of the Central European Summertime. That means not UTC +1 anymore, but UTC +2. So then we have some news from the ERCI network, starting with the ERCI Innovation Awards. We had one very successful 10th awarding ceremony last year during the InnoTrans at the booth of our ERCI member cluster CNA. And some inspirations you can see on the video. And in Milan on the 30th of September 2025, there will be the next awarding ceremony. And for the time being, the clusters belonging to ERCI have already started their regional and national contests. And please contact them and be informed. During this website, we have posted a special article where you can find any necessary information to apply to these ERCI Innovation Awards. First, at your national or regional ERCI member cluster, and in the second stage, each of these 18 ERCI member clusters have the possibility to nominate up to 3 applicants for the European contest. So, some current ERCI activities regarding internationalization. It is first on the railway interchange. We will have a small ERCI booth at this fair in Indianapolis, taking place in May this year. We are positioned in the exhibit halls A to K. That is the area of the REMSA Association, and our booth number is 2946. And we also are planning an ERCI delegation. If you are interested to come with us to the railway interchange, please find the details on it at the website of ERCI. Then we are in preparation of an ERCI mission to Canada, and it will take place from 8th to 12th of September. Some organizational issues have to be done, and further information will follow for sure also on the ERCI website. Yeah, there's another exhibition possibility for ERCI cluster members. It is at the 9th Railway Forum in Berlin, taking place from 2nd to 4th September. The competence partner of the Railway Forum is Deutsche Bahn, and you can get directly in contact to the organizer of this 9th Railway Forum, IPM, if you are interested to exhibit as a part of the ERCI village at this fair. Please find more details here. All the links you can find in the chat, and by reading these links or reading the details, it is pretty much clear on what to do. And for sure, if you have questions, you can contact us directly. Yeah, saying some words on the Horizon Europe work programs for 2025, including for maybe the most interesting cluster 5, climate, energy, and mobility. There is some information already available. There are draft versions of the Horizon Europe Work Program 2025 for all clusters available. There will be the adoption of the work program 2025 to be expected to be adopted by end of May, by end of April or early May 2025. And there are already indicated some Horizon Europe info days for several clusters. For cluster 5, it would be the 6th of May, but you find all the details by following this link, the last one indicated here on this slide. And Guido is so kind to put all the links into the chat. So reading the chat might be a very, very suitable and fruitful thing for you. So further, there's not only Horizon Europe, and speaking about European funding, there's also the European Space Agency, ESA, which has two open calls available. And the first is Space for Intermodal Transport, opened at the 10th of March this year, will be closed on the 12th of September, and Space for Rail. It is already open since years and will be closed latest on by the end of this year. And both of these calls, including feasibility studies as well as demonstration projects. So if you have a project idea or interest to contribute, please do not hesitate to contact ERCI, Guido, me, or both, or use the contact at euraclusters.com address in order to collect your interest and see where are the possibility to include you At the moment we are discussing within developing consortium of the space for rail, and they asking us also to propose some small medium-sized enterprises, and maybe if you have some idea, please or interest, please get in touch with us. So. Coming to some projects, ERCI or clusters of ERCI are involved, and I will hand over to Guido because he is the master of the LEADER 2030 project. Guido, please.
Thank you, Lutz. I'm not the master, I'm just a representative of this very interesting project, LEADER 2030, which is aiming to suggest measures that contribute to strengthening the resilience of European supply chain for raw material for the railway sector, according to the R&D, Research, Development and Innovation project developed under Europe's Rail. ERCI in this project is the coordinator, but we have also RAILenium, the technological center based in Valenciennes in France, JKZ, the mining cluster in Freiberg, and Technopark Istanbul in Turkey. The project is still ongoing up to December this year, and you can find all the connection and details on the website, on LinkedIn, or please, if you are interested, also register yourself to the project newsletter. So this is the first point. The second project is the project Idealist. The coordinator is SIM, a French cluster, and Idealist goal is to empower SMEs in tackling supply chain disruption and boosting advanced technologies, the 14 which have been detailed by the Commission, to uptake in 3 key industry ecosystem: energy-intensive industries, aerospace and defense, and mobility, transport, and automotive. Here we are present as a DTECFER, one of the 18 ERCI clusters, but we are with other 13 partners representing 9 countries. Why we are putting this, you see also here the project news, the website, the LinkedIn, and the event where you can register. And we are presenting this project, the European project, because just a few words on it. It's based on 4 main pillars. The first is strategic foresight, preventing and trying to foresee the future and how to better work in a resilient world for European SMEs. The second is technology uptake. The third is supply chain resilience. And the fourth is collaboration and networking, which introduce the next slide, please, Lutz, to one of the activities that the DTECFER is managing in this project, which is the Hack and Match. We have already done the first Hack and Match on advanced materials, while now we are in the middle of the second Hack and Match, which is based on AI for the digital and physical worlds, where we want to try to find solution integrating the transformative potential power of AI in product, services, and organization. We are in the middle of this call for challenges, so each company is able to promote and to detail some of its challenges. We invite you to use the link and to register yourself. Maybe you are an AI solution provider, so waiting for the challenges, the collection of challenges, then you will be able from the 23rd of April up to the end of May to answer with your solution to the challenges which will be published. Yes, then we will conclude with 2 days of Hack and Match, where challengers and solution provider will meet and work together. Then in July, we will have the awarding ceremony where we will have one winner and one coup de cœur. Next slide, I leave the floor to my colleague Irina presenting eBoost project.
Hello to everybody. I hope you hear me. Yes, thank you for this opportunity. I will present shortly the Boost project that we partner of it, and it aims to ensure a large coverage of electromobility at the European level, and we focus to create a strong and dynamic platform for e-mobility stakeholders and increase their cooperation and provide value chain. So we have 6 partners, as you can see, from Europe, next slide, please. So in the next months, we are organizing 3 different events. One of them is on 18th of March, is the matchmaking event that will take place the whole day. And it is organized in collaboration with Forum Stars project and the ERCI community. So we try to gather all diversity of our SMEs, and not only. So we invite all the companies to register to the matchmaking event and to create matches and collaborations. So we will share with you these links to enter and see more details. Beside the matchmaking event, the same day, we are organizing 1-hour webinar dedicated to hydrogen. So with the topic how SMEs in automotive can adapt to changing markets and demand. So you can also click on the link or scan QR code to go on and register. And as last, but not the last event in the Boost project, so we have much more in the next month. So we are organizing the Investors and Sponsors Day on 9 and 10th April in Helmond, in Netherlands. So it is an event open to all interested companies, and it's linked to the conference on innovations in automotive mobility. This event is organized by ANL, automotive cluster in Netherlands. So we would be happy if you will register, and so we will see you there. Thank you very much for this opportunity, Lutz.
Yeah, thank you very much, Irina. Also, thank you very much, Guido, for your introduction to these different projects and these different opportunities to take part in this project. That is the most important issue in order to get in contact, to find new fruitful contacts due to these projects. So yeah, the last slide, it is the feedback questionnaire again. We would be very pleased to receive your feedback from this webinar. And yeah, we are, it's 11:30 in Europe, in Central Europe. That is the end of the webinar. All the best to you. And let's see again, maybe, if you are interested, in 4 weeks on the 9th of April. Have a nice day. Bye-bye.